Um, Welcome.
Thanks.
I'm assuming everyone has seen the website and downloaded R. To do is start get get some ideas of how we need to format our data, and then how to put our data into R, and then if we have time, we can start analyzing that data. But I think the number one thing that stops people from using R is the command line and getting your data actually onto R. Of an introduction to what R is.
Yes.
So R is a command line program that runs a lot of things. Stats is what it's really good at, but it can do data management. It can run scripts that do other processes. It can do logical programs like called for loops. It knows if else statements. So like if this thing is true, then do this. If not, do this. This sort of stuff. So you can basically have R do whatever you want, and that's kind of the how R is built. Everything is sort of a front end of a bunch of really sometimes really simple, sometimes really complicated logical arguments and logical statements. So this is the GitHub website that you've all seen. The really only important things on here, there's 3 files, readme.md, which is, MD is a markdown file, it's just an HTML file that, or a file that's read by a website and expressed as a HTML. That's basically what this is right here. If I add extra things to this, links you need to go to, or things that I thought might be good resources, I'll put it on readme.md. The other 2 files are the mydata.csv, which is a fake data file that works with R, and then the seminar.r file, which is an R script, which is one of the great things about R, that you can write a text file with every command you could ever want to run, and you write it once, and you never have to write it again. You can edit it. Some people, when they start using R, go right into the command line and just write everything by hand. And if you do that, that's great, but then you have to do it again the next day. You have to write it all in again. And if you make a mistake somewhere halfway through your writing, you can't go back and fix it. You have to start from scratch. These 2 files, rHepHistory and rHistory, were generated by my Mac. Every time you open R, it remembers what you did. They're not necessary for you. I'm going to figure out a way to get rid of them, but you can just ignore those files. Most of your computers will make those files, just never see them. The 2 important downloads. First is R. Are you successful at downloading R and figuring out where to go? I always suggest, it says please download R. Please choose your preferred CRAN mirror. Just go for the something that's closest. So I usually do Michigan because that's where I lived when I learned R. But as long as you're in the United States, it's fine. I think Mike tried to do one in Denmark, and it took more than 2 seconds to load. So we got a little bit upset. The newest version is Fire Safety. Their naming system's really funny. I think one of them was like Cobblestone Sidewalk or something. Another one was like Jellyfish Explosion. I don't know. But usually if you're 1 or 2 versions behind, it's okay. Mac and Windows users can't update R automatically. You have to go onto the website and download it. But as long as you stay within like the last year or 2, you should be fine. The only reason why you need an updated version is if they have new packages that you're using that are specific to R that aren't compatible with older versions. Let's go back. And then the other is RStudio, which hopefully you all downloaded as well. This works for both Mac and PC. It's a we call an integrated development environment. It gives you a front end for R, so you can work with, you can have your plots, you can have your data, you can have your script, you can have your console all in the same screen.
So by downloading that, what did I do differently? Because originally I just had Yeah, those two little desktop R icons.
So that is R itself. You have to download both R and RStudio because RStudio doesn't come prepackaged with R.
Okay.
It's basically just a front end that searches your computer for R and then so first off let's open up RStudio. I don't have it there. But basically greets you with this. It greets you with a console, which tells you your R version and all of this other stuff you don't really need to know. And then you actually have four. And so what you have are there's four boxes here. You have your environment and history tabs here, which usually you don't really need to worry about. You have this top box, which is your R script. The bottom box is the console, which is actually the running version is R. That's being run from that R program that you downloaded prior to downloading this. This lower box has a bunch of different things. It has your plots. So if you call plots from R, all of them will show up here, and you can export them. Packages that you may want to install, which we won't worry about today, but there's a bunch of things that you can install in R to do specific functions. Help if you want to search it as a file explorer, so you can actually look up your things. So I think what we should start with is, and on the top you have all of your file options. So why don't we open up a file and open up that .r seminar.r program that you downloaded. Find under here. So the seminar.r file. Great. So now that we've got the script up, this contains two different types of messages. We have everything that's closed by number symbols or hashtags. And those are comments. So everything that's commented out is stuff that I want I want it in the file so that I can remember and I can read it. But if I try to run it in R will just ignore it. But everything else, so starting on line 13, I see y equals c, y arrow c, all of this. This is not commented out, so this is something that R can actually read.
Okay, so literally, if you just put a number sign before it, it's just
Yep.
a state. It's just a statement.
Yes, and it's good practice when you're writing an R script or any script to comment everything that you do.
Right.
One, so you remember what you did, and two, if you ever share it with someone,
They can see
what you did.
Gotcha. So it'll stay there. It's just the program's not going to do anything.
Right. So let's do that. So let's input our first line into R. So on line, if you scroll down or bring your cursor down to line 13. What this line is simply we want a variable that's called y. We can call it whatever we want. This arrow, which is a or less than symbol and a dash, basically works as an equal sign. So everything after this arrow is what we want y to be. This C stands for concatenate. You don't really
Why is
need
it equal?
Well, it can be equal, but I think it's better practice to use an arrow because equal can also mean be in an equation. So you don't want to, and then there's also an equal, which is a little bit different. So I think, yeah. So I whenever I teach anyone using R, I always suggest. And when I learned it, it's like use the arrow for this. Don't use an equal sign. It's synonymous, but it's easy to get confused. So the concatenate means that we want to put together a list. So you don't have to remember that C means concatenate. Just remember that C is to put together a list. So we want a list, and it's going to be 1, 2, 3, 4. It'd be five data points long, and those data points are going to be 2, 3, 4, 5, and 6. And I put a comma in between each because I want them to be separate numbers. Without the comma, that would turn to 23. With a space, R would error out and stop reading it. Because if there's empty space between anything without a comma, R just stops. This space is fine, but anything within your command, if there's a space, it's just going to error watch. See, unexpected numeric constant and y, blah, 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 blah. You know, it'll error out. So make sure those commas in there. Make sure they're commas, not semicolons or colons. Those are different things. And so what you do if you want to put this into R, you can copy and paste it. You can paste it right in the bottom here, and then press enter. So and that's fine. But really, if you want to be slick, you just push Control Enter, and down it goes, and it will already run.
Anywhere in the line, you can just press.
Yeah, as long as you're in that line. So if I'm down below it, it'll run that lower line and won't do anything. So you have to make sure you can also if you want to do multiple things, you just highlight it, Control Enter, and all goes in.
You're using Command Enter?
Control Enter. I think Command Enter also works. One thing about the RStudio or the R console, it gets really messy really fast. If you want to clear it, just push Control L. While you're and everything's still in it. So you can use arrows to go up and down everything that you've done. Does that make sense so far?
So that top arrow is just when you're going up, it's reading the lines that you just made disappear.
Right.
It's just showing the line.
Right, and it's also you can also rerun that command if you need to.
I see. That's cool.
And I'm in the console right now. I'm not up for the thing. So so we've inputted. So let's input both y and x. And then what we can do is we can simply in the console we can write y in, type y in, press enter, and we get our list of 2, 3, 4, 5, and 6. The 1 designates that it's one row. It's 1, 2, 3, 4. Yeah. So five numbers in one row. Same thing with x, and it is 5 numbers in one row. And then, okay, so what are we going to do with these points? This is usually what I do to make sure R is actually working every time I download it. It's never not worked, but sometimes it does, so I'd always do this. I always do y equals random numbers, x equals random numbers, and then I plot it. And the way you plot is really simple. You call a plot function, and then within the parentheses of that function, you have your x value and then comma y value.
I'm sorry, can we go back? How do you...
Yeah. So what we can do to plot is we just call a plot function, plot x comma y. If you want to do the y first, it's y squiggly x. If you do y comma x, y will be treated as x, as the x-axis, and x will be treated as the y-axis. R doesn't actually know that when you say x, you mean x-axis. It just means x is an arbitrary name that you gave. So this is a plot, comes over in your plot box. We have our 5 points, and they're so for on x when x was 2, y was 3, when x was 3, y was 2, etc. And what we can do is we can export that as an image file or a PDF file, which is really cool. There's a lot of things you can do with the plot. You can change what this y-axis says, what this x-axis says. You can add a title. You can add lines of best fit. You can change the limit of the axis limits, all that sort of stuff you could do in Excel, which we're not going to do today necessarily.
So you
but
can't do that there, right? You gotta get it in Excel, and then you can.
No, you can do it here.
You can do it there.
Yeah. So
If you look at this, you see like
So-
all this stuff there.
yeah. So
Cool.
I'll write
You
one.
can
So
change all the colors, you can change the
Okay.
titles.
So you do everything right in the console.
yes. So here's an example. So plot. So x y.
So you just
Right. And then we want to say we want a title.
So this here is a variable.
So title equals, and then we want to do this in parentheses because it's not a named thing. We want these actual words.
All this stuff.
Title
So that's what this is. Count data.
our plot, and then x label, x lab
Let's do reproductive status.
equals
You can just do this
fake
directly
x,
from this.
y lab equals,
Just took it directly from here. And he'll show you how to
fake y,
code that, because that's a
and then
that's really how to
actually
input
this
data.
is
Then it's
You
like-
can
going to be there.
And a
Okay,
lot of
so
this is
and we
teaching
run it,
response.
warning, title. Oh, it's not title. It's main. Title is if you want to add in a title
Main,
after the fact. Title is a function. So main.
Well, what's it say?
So it's main instead of title.
M-A-I-N?
Yep.
Yeah.
As in the main title.
Oh.
And then listen, so I can change everything.
So you have spaces between main.
And yeah, that's
Oh.
okay.
Yeah, so that equal. Do you need those there? If you don't put
No,
those there,
it can do that.
Okay, gotcha. I was just curious.
Yeah, actually, that's probably why I don't know why I got a warning, but yeah, the space. What R will realize is that if there is a call, it will look for an equal sign. Then once it sees the equal sign, it will then look for your call. So if there's a couple spaces, it's okay.
Gotcha.
At least one space. I don't. Is it two? Okay. Yeah, it's okay if there's two as well. Because you can also have these on multiple lines, as long as you don't break your the logic of the function. So if this was one line, and then you had main on the next line, and then you had ylab on the next line, that's fine as long as you keep these commas. So if this comma has disappeared, and then you put a space, it would break the right. Does that make sense, everyone?
Mm-hmm.
So that's very basic plotting. You can do some really intense stuff with plots. There's a lot of functions. There's called ggplot2, which is a function of that somebody's written, a package somebody's written that has a bunch of really cool stuff you can do. You can do error bars. You can do different types of plots. You can do different types of, you can do 3 plots, different colors, all this sort of stuff. But all of that's much more advanced once you start playing around with R. It might be, I think that once you know what you want to do, then it'll make it a lot easier to actually figure out what you need to learn and which to do it.
Is there a good way to search for packages like that? Like, is it pretty easy to know what sort
Yeah.
of packages you need?
So-
a good description.
Yeah, so actually, so you can do it 2 ways. You can do it in R, or you can do it on Google.
Right.
So our documentation is pretty good. So let's say we were interested in the plot function. We know it's called plot. And what you do is you put in a question mark. I have a question. And then the function name. In this case, it's plot. And then on the right bottom here, it will give you the documentation that the person who wrote the program wrote. Sometimes it's good, sometimes it's shit. Mostly it's okay. And it'll give you what it is, what the function usage is, what each argument means.
Mm-hmm.
And then the ... indicates graphical parameters, which are those things like title and main. Click on the link, and you can get a whole list of them.
So those are all the things you can do.
Yeah, so you can adjust the text screens. You can change the size of the axes, the different function or the different fonts. You can do all a bunch of there's hundreds of things you can do.
Very cool.
You can change the labels. You can change the colors. You can do little silly boxes. You can do anything.
Very cool.
You just have to know what the call is. If you're not exactly sure what you're looking for, but you have an idea, you can do what's called a fuzzy search, which is 2 question marks. So we don't know exactly what the name of the function is. So we're looking for just graphs. So I'll enter, and then it will just give me a bunch of vignettes and help pages that have to do with graphing. In this case, graph is really common, so I get a bunch of things like volcano something, which I don't really care about. But we have diagram R, we have ggplot2 here, which is that plotting library. The graphics library. You got all these bunch of different things that will do different types of graphics for you. So if there's a certain specific graph you want, you can just search it, or you can, fancy plots in R. Yeah, ArcTutorials, more and fancier graphics. And then there's a bunch of,
Great.
right. And this is actually not a great one, but there's and they're everywhere. People do, people spend hours making this stuff. It's
That's-
stupid. It's
that's the
stupid
best-
how much there
That's
is.
the best thing about R is the open source
Yeah.
thing. There's just any problem that you ever have had,
There's nerds working on it.
there's somebody
Yeah.
who knows it. So like
Yeah.
you Google, like I Google problems all the time, and I'm just like, okay,
Yeah.
whatever this problem
Even-
is statistically or whatever,
Yeah.
and there's some package. for
Yeah,
it.
and if you're having an
At
issue,
least
someone has had that issue.
right.
So I mean, fancy box plots. I'm just gonna fancy box plot. It's incredible.
Screams yellow.
Just waiting for you to search that.
Done. Just
Um,
wait for you to ask.
So that's the basic usage of R. We tell it what our data is, or we give it data, and then we tell it what to do with our data. It won't be able to do it automatically, which there's no program that can. But without having an actual user interface like SAS does, or Minitab, or any of those programs.
That's what our studio is.
Right, RStudio is kind of gives you sort of you still have a console window, but you have a little bit more control.
So do
Type it every single time. Like running your analyses shouldn't be a chore with these. Once you know how to do it, you write it once, and then even if your data changes, you just run it from your thing. Always save it as a .r because R can read those directly. And you can feed it into RStudio. If it's a text file, it won't work.
Can you show how to do that really quick?
Yeah.
How to save something?
So if you open 7R and you change it, you can just save it right here.
Okay.
You can also go to File, New File, RScript,
Okay.
and there it is. And
So you can start from scratch there.
yep.
Okay.
And then you save as file. You save it, and then you save it wherever file you want. And I would suggest saving it with your data. You can be fancy and like save different things in different files when you get better, but I think when you first start off, keep it all in the same file because it makes it easier for R to find your data. So we'll go over that in a second.
So basically, you could write the code or the line for whatever you call it, the line for an ANOVA, and save it as an ANOVA, and then every time you open it up, you can just plunk your data into that, and it's going to
Yep.
do it the same way.
Absolutely.
Okay, that's awesome.
So so you
So,
can do
like,
that.
Say Justin like tries to write an ANOVA and he sucks at it. And then,
Oh.
and
That's
then
no
he's
stress,
like,
man.
he's like, Matt, I really like your ANOVA file that you use. Like, you can just send it to him.
Yep, or he
And,
can
like,
send
a
me
regular-
as .r.
Yeah.
Yeah,
Or
he'll-
he could send you his.
and I
he
could
could
fix
make
it.
less sucky.
and I could fix it and send it back to him.
change was the data.
You shouldn't have told me.
Like you could
Yeah.
just edit one line on
Yeah.
there, and you could just change what data is inputted.
Yeah.
And still run the same analysis that he ran.
That's
Yep.
so cool. So
100%. So that's why this file exists because it works.
That's rad.
Period.
Yeah.
As long as you have when we get to the data input, just to make sure you have that data file.
Right.
So R is, that's the same way with most programming languages. Is this ability to compartment to have everything shareable.
No, I
It's like a
understand.
small
why it's so cool.
program.
Yeah. And there's like things up here like Sweeve is a thing that there's different files up here. Like I actually don't know what our presentation is. I don't look into that. But like Sweeve is something with this file language called LaTeX, where you actually use to write manuscripts and things, and you can actually run R in your document. So you're writing, and then it's like, oh, I need a p-value. You have the R in that file, and then while you're writing, you just have it source that extract the p-value, and then it's automatically in there. You don't even have to type in your p-value.
Use that?
Oh yeah, I don't type in my own stuff. Like I do my best never to manually do anything because I know I'm gonna screw it up if I do.
Really.
So,
That's really, really cool.
So that's how the basic way of doing it. The next level is to get our own external data into R.
Mhm.
And so this is what gets a little bit more complicated. So what we need to think about is working in our what's called a working directory. And this is the file that we, it's a folder that all of our data is in. In your case, it should be the same file that your R scripts are in. And so if you're not sure where your working directory is, you can do a couple things. You can write the function get wd with 2 parentheses, and that'll tell you. So my directory right now is users matl. So this is in my main folder area, or my main directory. Another way you can do it is you can go to session, and then you can actually change your working directory. This is probably the easiest way to do it. You simply go to choose directory, and then you can open up whatever file you want, and that's going to be your.
So like say you have an R file where you put all your R stuff, you would
Yes.
make that your directory.
Yes, as long as your data is there as well.
Okay.
If your data is in a different directory, you make the working directory your data directory. So you can have all your R files in one file and all your data in the other file, and then have all those R files get the data from the data file. It doesn't all have to be in the same file, but I think when you're first starting off, it makes it a lot easier. Another way of doing it is you go to session, and then you, actually, where is it? I never use this, but I think it might be good to do. You can actually source based on your, oh, here we go. So you set working directory, you can choose directory, or you can source file location. And that means, so if your data is in the same file as your .r, you just push to source file directory, and then it automatically does the command to set the working directory into that folder. In this case, it's in my GitHub folder under scientific commuting /r. Does that make sense?
No, you kind of lost me there.
Okay. So there isn't a command. So the command to see what your working directory is get wd.
Yeah.
To set your working directory, it's simply set wd.
Yeah, I got that far.
And then you can, in parentheses, put our or in quotations, write explicitly what the entire file extension to get to, or or folder directory information.
Wherever your data is.
Right.
To get where your data is.
Right, but
Yep.
but since you're using RStudio, it's super easy. You just go to session, and to set working directory, you can either set if your data is in a different folder, choose your directory. If it's in the same folder as your .r file that's already open in RStudio, you just source the file location, and it'll automatically write all that in for you.
I got you. Okay.
And the setup is a little bit different for the syntax is a little bit different for Windows and Mac. Mac uses /. PC uses / between folders, so which is a pain in the ass. But that's why you just don't worry about it. Just do this.
Gotcha.
So now we're in the correct working directory. We now need to put our data in. So I want to call my data. You can call it whatever you want, but be consistent, and also don't name multiple things the same thing, because that will error out every time. Also, there's what are called reserved words, or reserved functions. So things like mean, MEAN, or plot, or data.frame, or matrix, or square root.
So if you use one of those, you're going to get an error message.
We don't get an error message, but if you ever go back, if you're within the same session, if you try to, let's say, I want to call my thing SQRT because I'm taking a square root, and then I go to take a square root and use SQRT, R will error out because it will think you're talking about your
your
data
file.
instead
Gotcha.
of the function.
Okay.
It won't be able to tell a difference.
So, yeah. Okay.
So be descriptive, but be creative. Don't use very simple things like, and people do this all the time, never just call it data, because that's also reserved. Usually there's not an issue, but I see a lot of people that do that, and I think it's just bad practice. So you can do that, but I just do my data instead. And so how we do that is, so you call it my data, and then you put that arrow. So everything after this is called my data. And we have two different types of files we can use. We can use a comma-separated value sheet or a text file. The file that I gave you on GitHub is a .csv, which you can open in Excel. It's just a regular Excel sheet. The first column are column names, or column headers. and then everything below that is a observation. So this row is one observation. I have observed this individual at a weight of 10, final weight of 10, height climbed of 3, final instar of 7, is initial weight of 1, food type, and then sex. These can be both numeric and character. So as you can see, 10 is numeric. Control is a character. It has letters in it. It's a factor. I can group it. I can group things by food type. I can group things by sex. But as long as you have it in this setup.
Your batteries low.
Oh, that's not good. Okay. Okay. Did it actually do anything on we good. Alright. That should help. So what you want to do is
Are these Manduka?
Manduka and there's some Manduka, there's some fly stuff. This is all fake data.
Okay.
Height climb is a Drosophila thing.
Okay.
The one thing about using a text file or a CSV file is that anyone can read it on any computer ever. As long as your computer can take files in, it can read a .csv or a .text. So you could have like an old, a Mac 2 and it probably will run it. Downside is if you ever have an equation that you use, the equations will, as soon as you save this, the equations will disappear. So,
CSV.
yeah, because all this looks like, so if you can open this.
So you should save it as an extra document. Don't replace your Excel file.
Right, if you need the equations.
Yeah. Right.
Or you can write them on in a different CSV file. But let's see, I'm gonna just open it in a text edit. Because this is what it looks like. It's really simple. You can actually do these on your own. It's just, just separate by commas.
Yeah. Just,
So, so the way we insert that into our Studio is we have the command read.csv, and then we in quotations we put the name of the data. You can also put the entire file extension, or the entire I can't remember the word right now.
So like documents.
Yeah. Slash
Yeah,
documents. Yeah, you can do that all you want, but if you're in your working directory, it will look for this file in your working directory.
Okay.
So we can, and then we also want to say h equals t, which means that the header is true. So that first row will be our column names, it won't be observation. So if you don't have column names, which you really should have, it will automatically generate them. If you don't do h equals t, it will automatically generate them, and the first row will be considered an observation as well. So
Just do H. That's the header.
yeah, it's the same.
Awesome.
Can you say that one more time, Matt? What the h equals t means?
Yeah. So h equals t is header equals t equals true.
Oh, okay.
So the header,
Okay,
yeah,
gotcha. So,
but a shorthand is h equals t.
so that just tells the program, don't pay attention to my first row.
Yeah. It says that use my first row as my header.
Okay, not as data.
Right.
Gotcha. Okay.
It'll still be in there. It'll just be as the
Gotcha.
So without it, it makes headers, but treats your first
treats it
Your
as
first
data. Makes it
row
As the header.
as data. Well,
No,
it makes.
it makes your second row your first row of data.
Yeah. Okay.
Yeah. Sorry, I don't know why my thing's not hiding. All right. So the other way of doing it, if you have it saved as a .txt, which is also comma separated, it could be space separated instead of comma. It's read.table instead of read.csv, but everything else is the same. Now you can check and see, make sure your data was correctly inputted by running names. The names function. This will extract your headers and your column names. So you run that, and then I have the final weight, height climb, final instar, all of that. It's all in it. You can also look at the whole thing by just simply writing my data. And there's your data frame right there.
Alright. No, I want to do that. I'm gonna try.
Let me see what my battery's looking like here, because I'm recording this. That's probably why the battery's. I have about 16 minutes. We'll be okay. Hopefully, I'll just re-record. I'll re-record
Just go
this.
get your thing right now.
And what time is it? 11:35. I think it's okay. If I have to re-record this, I have to re-record this. All of this mess anyway will be edited out anyway. So now this is a bunch of things we can do with our data. And that's pretty much where I want to end it today. We can call specific columns by saying, okay, I want to look at my column named final weight, which is my first column. I just call my data, which is what I called my data. Does that make sense so far?
Mm-hmm.
And then use a $sign, and this basically says to R, after this $sign, look within this data frame for this column, named this. And you run that, and it'll give me all the numbers, all the observations for that column. You can also do it numerically. So the way it's set up is an x comma y setup. So the first column, I want to look at the first column. I don't remember the name of it, but I want to look at the first column. It's my data, comma 1. So we want all the rows, so we leave it blank, and we want the first column, so it's comma 1. And then it'll be the same. It's basically the same command as the first one. But now I'm interested in I want the first row. I want to see all the observations for one row. So that would be one. That would be, and this is in square brackets. It's very important the shape of the brackets you use. So now it shows me all of my my column headers, and then gives me that entire row. And then if I want to look at one particular item, I want to look at that one point in the second row in the third column. It's 2, 3, and it gives me that's a 4.
So
I don't know what's useful for that. There's the usefulness for that is when if you want to do specific things to your data and manipulate your data, you can call things specifically.
So
But
square bracket is giving it coordinates within your data.
yes,
essentially.
yes.
And
Yeah.
by leaving one blank before or after the comma,
It just is everything.
using that whole. Okay.
Yeah, the whole row or the whole column.
Yep.
So, and then you can do really simple summary statistics. You can get the mean, which is, it's mean. The command is mean. So I called it mean.fw. So you can mean fw. That this is the mean of my final weight column.
How does it know FW is final weight? Just because its first letters before and after the.
No, this is arbitrary.
Oh, okay.
This was completely arbitrary. This is the name I gave it.
Right.
You can run this on its own. Like
Okay.
if I was to do this, just run it on its own, it would just come right up.
Yep.
So but it knows that I want the mean of the final weight column within my data. Standard deviation is also a built-in function. That's SD. It's run the same way as mean, and that will give you an SD. You can also get the length of your. So you can get the little n. To see the number of observations you have. So that's that's the length function. It's the length of that column, or you can do the length of that row.
Mhm.
Actually, rows should all be the same length, right? Because you've got. And the reason why I named all of these is that I can also get standard error. But standard error is not a built-in function. It's something you need to do on your own. So I have standard deviation divided by the square root of n. Because I've already called these two, so I don't need to. You can write all these out explicitly, or you can give them names and make it simpler. And as you run that, oh whoops.
So if you put something before the arrow, that gives it a name that it will recognize in the future. If you put something after a pound sign, it's just for you.
Yes, absolutely. And so if you run SCFW, it has calculated my standard error. Because R in the simplest form is a multifunction calculator.
Uh-huh.
Everything plus, minus, divided, all of that is simply put in just like a calculator. Does that all make sense?
Yep.
And then you can start doing you can actually start doing stats. So this part probably requires a lot more time. But let's say you want to do a t-test, and you already know that all your assumptions are correct. You don't really care about all of that. You just want to run the damn t-test. Surprisingly, the name of the function is t.test. And so you want your two variables, my data, final weight, and I want to compare final weight and initial weight. That's all I need. I need a comma in between, and that gives me my data. It tells it exactly which two data columns I want to compare. You run it, and it gives me a bunch of information. It gives me my degrees of freedom, which is 11. I think I have 12 columns, so that makes sense. It gives me my t statistic. It also gives me my p-value. And then it reminds me what my alternative hypothesis is, and it also gives me my confidence intervals.
Now, alternative hypothesis, that generated on its own
Yeah.
from the t function.
Yeah, because that's always going to be the
Always,
alternative
yeah.
from a t-test. You can also do a t-test with factors. So in this case, sex. So something that's not numeric is something that's a character. So instead, you have to use the squiggly line, which is shift, and then it should be the top left of your keyboard. That squiggle line basically tells R, all right, this is a categorical variable. And with a t-test, it has to be 2 levels or less. Or no, it has to be 2 levels, period. So in this case, male, female. So you run that, and then it gives me my p-value. So final weight and sex had nothing to do with each other. So 0.8 p-value, t is negative 0.14.
And I don't know if you said this, but the squiggle represents that you have the response variable and then the explanatory variable.
Yeah.
So I don't know.
So the squiggle will work with a numeric as well, but it has to be used with a character. If your independent variable, if your response variable is non-numeric, you need to use the squiggle. I usually use the squiggle all the time because I like it. It's fun.
Yeah.
It's fun. It's a squiggle. It's a fun squiggle.
Well, because I don't know. Like every time I see a squiggle now, it's like this is
Yeah, this given this.
right.
Right, and that's how I think too.
Right.
This given this, where the comma is like, commas are everywhere. So when I write things, I usually use the squiggle. I constantly use the
So if you
squiggle.
use a squiggle, don't use the comma.
Well,
If
you
squiggle,
use-
no comma.
right, but if you use the squiggle in a plot,
Yeah, that's-
X needs to go first, or Y needs to go first, because it's the squiggle. The squiggle means that it's Y given X, comma X2, X3, X4, X5, whatever. Where the comma means X and Y, or in a t-test, it's 1 and 2 because it doesn't matter which order. Does that make sense? Sort of. So the
pretty-
plotting gets a
pretty
little bit.
Yeah.
And then you can also run ANOVAs. There's a bunch of different ways to run ANOVA. I still don't quite understand all the differences, but I tend to like AOV. So that's why I always run my ANOVA in. It's the same setup as a t-test. You have your Y and a squiggle, and then you have multiple predictors. In this case, initial weight and final instar. And you can also run a ANOVA for more than 2 factors. So in this case, food type. The thing is about when you run an ANOVA, simply running it doesn't help you because I call it model.2. If I run model.2, it's going to give me a bunch of data I can't really do. It's going to give me my residuals and a bunch of stuff I can't really do much with. It'll give me a residual standard error, but not necessarily important. So what you can do instead is run what's called a summary function. Summary gives you summary for whatever you want. So you can if you do summary my data, it will give you the min and max of all your columns, all the means of all your columns, all this sort of stuff. Or, if you need that information, it's not necessarily something you necessarily want, but if you can kind of look at your data. If you want to look at an ANOVA, you do a summary of that ANOVA model, and you get your p-values, your f-values, your degrees of freedom. You get your ANOVA table, basically. And then what you can also do, which is really cool, is you can check your assumptions. So one of your assumptions is normality. You plot your model, and it'll give you 4 different plots to kind of qualitatively check your assumptions. So, model 2. So what I'll say is I hit return to see next plot because there's 4 plots. So as you hit enter or return, your plot will come up over here. So there's the first one. This is the residuals versus fitted. I think you want to see you don't want to see a flat line, or maybe you want to see a flat line. I'm not sure. But this is something this is when I teach this later, I'll actually remember it. But when you have a normal QQ, and this is this best fit line of your residuals, if that's a straight line, that's fine. But you can see it's not very normal. It's not a straight line. And another ones you want to see, you just don't want to see any sort of patterns. There's not a great pattern there. There's not really much of a pattern there. But these are things that you can research and use to check your analyses after you've done them, to make sure that if you're doing transformations or things to make your data fit assumptions better. That's actually everything on this particular script. So any
signaling
questions? Is this?
So signaling.
Do you think you could get your own data in to R?
Grouped here.
Yeah,
In this stuff?
Here.
yeah, I think so.
Pre-reproductive down.
I know.
Cool.
Yeah.
Well, so
like
what
said, like,
I
you
think
just
we should
Google
do
the problem.
is
That's really cool.
I think you should take this script and rewrite it for yourself, for your data, for either fake data or fake data that you actually have, and see if you can get it formatted correctly and see if you can get it into R. I'm going to put up this video, hopefully edited to make it a little more useful. And I think it might be a good idea if we kind of make this an informal study group. That if you're working with, I think Mike, that's one of the reasons why Mike's here.
Oh yeah.
Because working with this sort of stuff, I can give you intros till the cows come home, and it may not mean anything to you because when I first given an intro into this, I have no idea what I was doing. It really R requires you to learn how to manipulate the data initially, and then just play around and just like fuck up all the time.
Yeah.
You'll fuck up, and then you'll be great. And then you do it perfectly, and then you move on.